Yeah, so these, I don't know how good the notes are for everything else, but these notes are spot on what you need for this assignment, like 100%. With a couple of like minor errors in the notes, but like these notes are awesome for this assignment. All right, so the count in the bacteria culture was 800 after 20 minutes and 1800 after 35 minutes, assuming the count grows exponentially. Find the initial number of bacteria. So in order for me to be able to do this, all right, my function, this is my function that I'm looking at. So y equals a0, so a sub 0 e to the kt. So in order for me able to do this problem, I need to know the k before I can find the first term. All right, I have two pieces of information. I know that at 20 minutes, there were 800 bacteria cultures, and at 35 minutes, there were 1800. All right, so I can use this information to figure out what K is. All right, we're going to use this 1800 as the starting value, or the ending value, and this 800 as the starting value. Okay, so we're going to pretend like I know A1 or A0. So our starting, just for this example, our starting content, our starting bacteria is 800. E, we don't know K. And we'll talk about time here in a minute, but our ending value was this 1800. Okay, the time difference between the 20 and the 35, that's 15 years. So this would be K times 15. All right, so we're going to solve for K here. Divide both sides by 800. So your zeros cancel. And then 18 and 8 can both be divided by 2, so that's 9 over 4. Okay. So in order for you to be able to do this, section 4.4, with your solving exponential functions, you're going to take the ln of both sides. So ln of 9/4 equals the ln of e to the 15k. And what happens here is the ln of e cancels, because ln of e is 1. So the ln of 9/4 equals 15k. And then you're going to divide both sides by 15. So k equals the ln of 9/4 divided by 15. All right, now I'm going to go to my calculator. Okay, I have an emulator. All right, so it's not identical to the 84, but it's really, really close. I'll calculate 84 if you have an Apple. So I'm going to do the ln of 9/4 and get that value, and then divide that value by 15. All right, so I'm going to carry that decimal out as far as I can get it. So at least, I think I did 5 decimal places, but probably helpful to do a little bit more than that. So K is 0.05406. Okay. This gives me my percent growth. So now we're going to go back to this equation, and we're going to figure out what the initial value was. So let's continue to use this piece of information. Now that 800 represents the ending value. We still don't know A0. We know E. The K, percent growth. This is where the mistake was. Is the initial, this is after 20 minutes. And so I believe in the video she put 15 here when it should be 20. Because that 800 occurs after 20 minutes, not after 15 minutes. Okay, so I'm going to go back to my calculator. All right, so E, so that's second ln. To get that 0.5406 in your calculator without retyping it in, if you hit second negative sign, it pulls in the previous answer. You can retype it in, that's fine. But second negative sign pulls in your previous answer. All right, and then the year was 20, so we're gonna multiply by 20, not 200. And we get this 2 point, I gotta write it down. So I just found this value right here. So then my next thing would be to divide by that number. Okay, so we're gonna take 800 and divide by that 2.94. So again, 800 divided by, and I don't want to mess with retyping in that value, so I'm going to hit second negative sign, and that pulls in the previous answer. And so I got, this is what I got, 271.3396. And I believe she got something, I don't know what she got, but it wasn't this. I spent an enormous amount of time trying to figure out where I was going wrong, like why I wasn't getting the same answer she did. And then I realized she was putting in 15 instead of 20, and she needed to put in 20. All right, so now that I have this value, find the number of bacteria after 80 minutes. I know the K, I know the beginning amount. So Y equals 271.3396 times E to the K 0.5406. And this is after 80 minutes, so the time would be 80. All right, so go back to our calculator. Not that. Oh, I forgot what it was. Okay, so this 271, I'm gonna go ahead and hit second negative sign times E to the 0.05406 times 80. Right? Yep. All right, so 2020, so 20,500, give or take. Can we not? So it really depends on the rounding. So as much as you can put in your calculator, like don't round. Don't round it off. Write it out as far as you can get it. Okay, finding the doubling period. This is how you find double time. Okay, double time equals ln of 2 over K. So the double time equals the ln of 2 over that K value. So roughly 12.82 years. Is it years? Minutes, not years, minutes. Jeez. And then when will the number of bacteria go to 10,000? Okay, so we're going to set that equation equal to 10,000. All right, this is 100% calculated right now, okay? So the first thing I'm going to do is I'm going to divide both sides by this 271. All right, so 36.854. All right, now you're going to take the ln of both sides. So ln of e cancels. And let's see. I'm just going to write it down. And then you're going to divide both sides by that 0.054. Okay, again, when your calculator, you already have that 36 in there. So you're going to take the ln of that value and then divide that by 0.05406. All right, so roughly 66.721 years. Why do I keep saying years? Minutes. All right, that was the one place I saw that she'd made a mistake. I don't think I saw anything else as far as the mistakes, if there were any. But yeah, like 100% watch that video. All right, don't try and go into this without having done the notes for 4.5 because the video is so close, like right down to how the problems are worded. So close to your assignment itself. Okay. Now, with that in mind, are there any questions on any of the homework we have right now? And I'm more than willing to go over some more of these questions. Just know that the notes help incredibly with this. I actually found a way to get all the homework in as PDFs. Things I'm learning. That folder is not empty, you crap. As it takes forever to load. There it goes. Okay, so I actually do want to look at, let's see, not that one. Not that one either. This one at the end. So question 14 with the pH. Boy, if I had seen this problem without doing this, without like 4.3, number 6. Okay, let me do this problem, Laura, and then I'll do that one, okay? All right, so we have a pH of 4.25, so we know this value. And we want to know, so the H plus is the concentration of the hydrogen ions in moles. I don't know what that means, but we're finding the number. I'm just saying the number of hydrogens, okay? So the first thing I'm going to do is I'm actually going to divide both sides by -1. All right, then I'm going to kind of rearrange a little bit and kind of have them switch sides. And rewrite it in exponential form. So when you have a log like this without a base, it's log base 10. So writing this in exponential, 10 to the negative 4.25 equals the H plus. Okay. Now, when you put this in your calculator, you're gonna get something really weird. Okay, so we have this little E thing. All right, I'm gonna go ahead and write this E thing down. At least 4 decimals, 5.6234. And then it was E to the -5. So with this E to the -5, this is just its way of doing scientific notation. This means 5.62 times 10 to the -5. This is what it wants you to write in. Okay, I just learned what that little E thing meant today. I had no idea. I just thought it was a mistake. But now I know. It's scientific notation. Who knew? Okay, so Laura's asking 4.3, number 6. 3, number 6. All right, so remember, mine might look a little different than yours, but this is the same general idea. So this fourth root of C, right? You're going to rewrite that as an exponent. All right, when you're taking the fourth root, it is an exponent of 1/4. All right, so when you expand this, they want you to take that 1/4 and move it to the front. That's all you can do on that one. Anything else? Okay, I'm gonna go back to 4, 5. Let's see if there was another couple I thought was weird. Let's see. I mean, I honestly don't think so. 4, 4, number 18. Okay, so you're gonna add the 5 first. Now, with the awesomeness that is calculators, you're going to want to rewrite this as a logarithm. So the base of your exponent, that's 6, is the base of your logarithm. Its argument is the 15, and it equals your exponent. Okay? So if you have the 84 calculator, I don't know if this is going to work. Hopefully it does. Alpha window. It does. All right. So my emulator, I wasn't sure my emulator was going to do it, but if you have the 84 calculator, your button sequence is alpha window 5. So I'm going to type in alpha window 5, log base 6 of 15. So log base 6, 15. So I want to get this decimal. And then I'm going to go ahead and divide everything by 4. So we get 0.3778. 3 decimal places, 0.3778. So that's going to be 0.378, 3 decimal places. Okay. I don't know how to do it on Desmos. Let's find out on Desmos. Function. Okay, I don't know if I can get it to do it on my iPad. I want to try it on. Okay, I'm going to see if it works on my desktop. I'll share if I figure out once I get it to work. Okay. So I have discovered that you can do this in Desmos graphing. So let me show you. Let me stop this share. How do I stop this share? Okay, so I'm going to share this screen. All right, so I tried in Desmos Scientific and it didn't work. I didn't have a button, but on Desmos graphing. So let me show you. You would do log, and then you hit shift hyphen 6, 15, and then you see up in this corner right here, there's your value. Okay, so use Desmos graphing. Okay, what else can I help with? Okay, so your um assignment, let's take about 15 minutes. I just want you to work for 15 minutes. We'll be done at 6:45. Um, but I want to remind you, Tuesday is a virtual meeting. I know we already do online anyway on our Zoom calls, but this is not going to be like meeting on screen. I'll probably put a video in there for you to watch. Because I think next week's assignment is the Unit 4 review. So I'll probably pull some questions from that Unit 4 review and just push that out to you guys and then you watch that. Yeah, so let's take about 15 minutes. I'm gonna set my timer. 15 minutes of working and I'll keep an eye on that chat. If you have any other questions, let me go ahead and switch the screen. All right, so I'm gonna keep an eye on that chat, 15 minutes. Okay. All right, so 4.4, number 6. So we want to get the logarithm by itself. So I got it rid of that 9 halves. We're going to do that by multiplying by the reciprocal. So we get log base 5 of x equals 4/9. And then we're going to rewrite it as an exponential. So the base of my logarithm is the base of my exponent. Then you loop around to the 4/9. And you loop back around to the x. All right, so 4 decimal places. I'm going to head put this in the calculator. So 4 decimal places, make that 2.0448. Okay, does it help on that one? Perfect. Hmm? Whatever I can do to help. The expos and logs unit is my favorite one to teach. I like that one.